A very good afternoon to everyone. Thanks for coming here to attend this great case study on how VMware NSX is empowering a service provider, Rackspace, to help customers achieve and maintain industry compliance. My name is Anand Iyer. I lead NSX product marketing in the cloud provider program. And with me here is Luke. I'll let Luke introduce himself.
Hi everybody, I'm Luke Huckaba. I'm a principal architect on our product team within Rackspace that designs VMware products.
Just a quick reminder on the name change. VMware vCloud Air Network is now called VMware Cloud Provider Program. And a quick snapshot of the business itself. And also the benefits the cloud providers could provide for you. So we have about 4,500 cloud providers globally, and the cloud providers offer a variety of services. Examples include infrastructure as a service, managed hosting, cloud and cold and warm migration, disaster recovery, seamless connectivity between on-premise and the cloud, desktop as a service, and other value-added services. And we are the easy ramp to the cloud for existing vSphere workloads as well. And we also take pride in providing application tools that are similar on-premise and in the cloud. And it makes it really operationally effective for customers. So here's the agenda for today's session. I'll be giving an overview of the case study itself and a quick overview on VMware NSX distributed firewall, followed by then I'll hand over the ball to Luke, and he'll be going through the planning, implementation, QSA review, and ongoing maintenance for the solution that he and his team have built at Rackspace. So let's start by looking at what the case study is, right? This case study is about Rackspace's PCI DSS certification for management infrastructure and what it is not. I want to be really clear about what it is not. It is not about Rackspace's customers certification. Rackspace's customers must get their own certification. But the good thing here is that it makes the process of getting PCI DSS compliance faster for Rackspace's customers because the management infrastructure is already PCI DSS compliant. And I would also like to set the stage as to what the scenario is or was at Rackspace, what the problem was, right? So the problem that Rackspace was facing, was that, there were systems, many systems in Rackspaces, some of which, they had to be PCI DSS compliant, and some systems need not be PCI DSS compliant. That is a problem by itself, right? You have to solve that problem. So Rackspace had two options in mind. One is to re-IP everything, all the systems for isolation, and the second option was to basically go with, deploy VMware NSX distributed firewall for microsegmentation. And needless to say, Rackspace chose the right option, the best option, and they went ahead and deployed NSX distributed firewall for microsegmenting the environment. And before I hand it over to the next part of the presentation, I would like to ask Luke, why did he choose option 2 versus option 1?
So it was pretty simple. When we started looking at it, we had a single layer 2 with a bunch of systems in it. If we needed to go back and segregate that out, we'd have to create multiple new segments, which would cause us to have to create interfaces on all of the firewalls and route all the traffic through the firewalls, which could end up hairpinning and all kinds of different things going, moving forward, which creates a bottleneck, not to mention changing IPs of our management systems like the PSC or the vCenters and everything else that's integrated into the system. It's really difficult to go through and change IPs on everything after the fact. So after looking at it, it was a clear choice to go with the distributed firewall. It just made life so much easier when we deployed it.
Thank you, Luke.
Sure.
So here is a quick overview of the NSX distributed firewall. As you all know, I'm assuming that all of you have a technical background and know what NSX is. How many of you have implemented NSX here? Planning to implement NSX? Cool. So NSX distributed firewall is a software web that runs on each ESXi host. As you all know, it is a stateful firewall, layer 2, layer 3, layer 4, all the way up to layer 7. If you could integrate the distributed firewall with third-party vendors, and obviously the rules are applied to traffic between the VNIC and the vSphere distributed switch. That is the beauty of it. So again, it is a stateful firewall all the way from layer 2 up to layer 7. A quick overview again. So NSX for vSphere firewalling, again, as I mentioned, it is fully distributed and it is embedded in every hypervisor in the data center. And with this, it enables every virtual machine in the data center to have its own firewall. Imagine having hundreds and thousands of virtual machines and each virtual machine getting its own firewall. That is the beauty of microsegmentation. And there are many advantages to this, right? I mean, firewall policies are provisioned simultaneously when virtual machines are provisioned. It's very easy, it's dynamic. And obviously, policies move with the virtual machines. If virtual machines move from one data center to another, the policies are carried over. And obviously, if you're going to retire a virtual machine, it deprovisions the firewall, something that cannot be achieved easily with hardware-based firewalls, because you'll be left with, stale firewall rules in the data center. So with that, I'm going to pass the ball to Luke. He's going to take over and he's going to show us how he and his team at Rackspace have implemented a solution to achieve PCI DSS compliance.
So one of the key things is documentation is king. Document everything in your environment. We followed an outside to in approach as well as an inside to out approach, similar to kind of top down if you look at layered ACLs. What we started looking at was everything that was talking into our virtual environment, all integrated systems within Rackspace, our portal, licensing, KMS, WSUS, everything that manages your entire environment that vCenter is not inherently aware of. We had to document everything, ports, IPs, all that stuff. And then we started looking at what do our systems talk to, what do they consume, where are they pushing data to, or what other systems are they talking to, like even as simple as DNS. We had to know every single thing that our systems were talking to. So we audited all these traffic flows. One thing I wanted to point out, which would have made our lives a lot easier when we built this, would have been vRealize Network Insights. At the time, it was Arkin, and they were getting ready to go through the acquisition, and so it wasn't an option for us. It would have made life so much easier because you could see all those traffic flows. Whereas nowadays, if I could do it over again, I definitely would go with VRNI, look at the traffic flows. That'll help you with all this stuff here, but we had to do it manually. I looked at our firewalls, I looked at all the systems everything was talking to, internal systems at Rackspace. So one of the things we also had to think about was communication within the same vCenter. So VMs that are talking side by side, we had to know what integration's there. We might know there's a bunch of different VMs, but we need to know exactly what VMs are talking and what. Some are syslog servers, but they may not all use the default port of 1514. We also used custom ports, so we had to keep track of all that to be able to set up our rules properly. That's where the documentation came in. So thinking of outside to in, you have client systems, could be any application, whatever you're serving up, and it's talking into your vCenter environment. You also have other systems within your data center that are talking in through your firewall into that environment. And just, you could see green or PCI, blue or non-PCI, and they're all inside this environment. And as I was talking about, inside to out, what are we consuming at this point? Our VMs are consuming services here or possibly even consuming services here. But as I was mentioning a minute ago, you need to know about the communication here between these VMs, between non-PCI and PCI systems alike. So I used a spreadsheet to group everything together, and I'm going to show you this spreadsheet in a minute. And it's designed to look really scary. It's going to look overwhelming, and then as we go through it towards the end, you should be able to understand it. I'll show it to you again and see if it makes sense after we go through this presentation. So there are 4 key grouping objects to keep track of within NSX. Your IP sets is the first one. That could be a single IP. It could be a range of IPs. It could also be a subnet. It could be a group of multiple subnets, multiple single IPs, whatever you see that you have to kind of group into. So think about it as integration of your domain controllers. You say, okay, well, I have a local subnet where my domain controllers live, or 5 IPs that are domain controllers. You can create an IP set for those local domain controllers and put all 5 of them in there. And then you can use that IP set in your security groups. The security groups are kind of the main object that you assign policies to within NSX and Service Composer, which I'll get into in a little bit. But the security groups are groups of VMs, groups of IP sets. They could be static, they could be dynamic. You can also include security tags from, say, VRA. So if a VM gets built through VRA, it has a security tag, it can automatically be added to a security group. Extremely powerful and useful information just by tagging, and it's automatically added to your firewall rules on the fly, and you don't have to contact your network team to do anything. Now, services is exactly that. What services are you offering? The specific protocol and specific port. When you're creating the services, it's a single protocol. So if you know an application uses 5 different ports that are TCP based, you can create that service, TCP ports, and then if you know that that service also offers up UDP ports, you can add that on a different service and then create a service group, a single service group that contains all those services. A great example is all the VMware integrations, because they use a ton of ports, which I'll show you in a minute. I created different services for those ports and then a service group that contained all of those services. So here's my scary spreadsheet. Does that make sense to anybody? Anybody want to try to make sense of that? Yeah, one guy raised his hand because he's the one that helped me build it. So if you look at the very top, this is IP sets, and then my security groups, my services, and then my service groups. So there's what I was saying about the single service group for my vCenter services, and there's all the different services in it. But it's one object that I would add to my security policy. So let's take first look here. This is just kind of generic. I threw it together, just kind of made up some stuff. I have my IP set for my TVA, Threat and Vulnerability Assessment. So if I have a security team that needs to scan my environment and I know, their IP sets, I know their IPs, I can create an IP set and include them in a security group. So I can say, well, they can scan everything in my environment if they're coming from here. And then say, like, if we look my syslog servers, DNS servers, KMS, my United States domain controllers, my UK domain controllers, APAC, WSUS, all the different things that are going to be talking into my systems that vCenter is not inherently aware of. That's one of the key things when you're building IP sets. It's systems that vCenter is not aware of. VMs outside of the vCenter, everything talking in, that outside to in approach that I was talking about. And then in the instance of KMS, which is Microsoft, the key management server, they talk out. So I need to know what those IPs are that my systems are talking out to. Now here's the security groups. When you're creating security policies, you assign them to these groups. You can't assign them directly to IP sets. It has to be assigned here. So this is where I would create my security group for my TVAs, and I add their IP set to it. So now automatically, if there's a traffic coming in from that allowed IP set, it's a part of this group, and then is allowed to talk into my system on whatever rule I set. One thing that's really neat, like this local all servers, it's a dynamic group based on my virtual data center. So any VM that gets built or decommissioned gets added or removed from that all systems. My secured systems could be systems with an NSX tag for PCI. Could be based on specific naming. It could be a number of different things, or folder, VM folder, whatever you want to do for that one. And what makes it really neat is from there, I can say my standard systems is every single server that's in this all servers group, but exclude my secured systems. So by creating the standard systems based on 2 dynamic groups, I don't have to govern that group at all. Everything that's added to PCI is automatically removed from standard systems. So no more having to contact my security team. Oh, well, I need this thing moved. Say you build a new VM and you're installing the application and you need full access to it. You can remove the NSX tag and it's not, or the PCI tag, and it's automatically just into my standard systems. I have full access to it. I can install the application, I can get it up and running, add the PCI tag to it within NSX or within the web client, and it gets picked up and automatically added to secured systems, thus removed from standard systems. Now the services, this is kind of what I was talking about. You create each individual ones for TCP or UDP. You cannot mix the actual protocols within the services themselves. So if you have multiple services or multiple protocols for one service, you have to create individual services, link them together in a service group, like I did right here. So look at all those different ports that VMware requires. Just one vCenter services group. Now the security policies, this is going to look really confusing. When you look at it, you kind of think source and destination. Most of the time you think if I have a specific source, then you just talk to a specific destination. When you're building security policies, you have to step back and don't think about it that way. Think about it as a service that you are offering. And you say, okay, the TVA, the service I'm offering is anything. Anybody can access, or not anybody, but they need to be able to access anything in my environment. I'm not saying who yet, I'm just saying somebody can access anything in the environment. Another example would be the web client right here. So I have web client servers. I know I'm going to offer that up to somebody on HTTPS, TCP 443. So I create a policy that doesn't say specifically where it's coming from, but I'm saying it's a service that I'm offering to. And then I have Windows servers. They need to talk out to my Windows servers on my WSUS service that I created. But again, it's not assigned to anything. If you look right here, it says policy security group. Later, after I build that policy and I apply it to another group, and I'm saying I'm going to grant this group access, and it fills in anywhere it says policy security group, which I'll show you in a little bit. So here, if we take a look, we can see, okay, VMware services. My standard systems, my global network, and my local network are allowed to talk to my VMware services. My Windows servers were allowed to talk to Windows management, and then the web client says any 10. Address can talk to my web client. So now by applying that, it automatically creates these firewall rules for me, which again, I'll show later. So now let's talk about the implementation.
Just a quick question, just a show of hands. How many of you believe that PCI DSS is important to your business in the audience? How many of you have implemented PCI DSS? Okay. Planning to implement? Thank you. One other question for Luke. So you did talk about the planning process. So how long did it take from start to finish?
So the planning took a few months, all gathering the information, gathering all the integrations, everything, requirements that we needed to talk to, building out that spreadsheet. It went through multiple iterations, trying to figure out exactly what it had to be done, planning out the policies, how they're going to be applied. But then the turnaround time to actually do it was only a few weeks. We actually went from zero segmentation to full micro-segmentation in a matter of like 3 months total time. And we ended up becoming the kind of model citizen within Rackspace. Our security team went to other teams and said, okay, look at their documentation, look at how fast they did it, look at how they implemented it, and this is kind of what you guys need to follow. So it was, we got to kind of nod to everybody like, yeah, we built this thing really fast and really good, and it passed.
And one other thing is, any recommendation for the audience in terms of the planning process?
Again, VRNI. Make sure, I mean, if you can't do VRNI, it's going to take you months to probably figure out all your integrations, but document everything. Keep track of that documentation, follow the documentation. And if there's something that you missed, add it to the documentation first, because you don't want to add it in, say, Service Composer or something, and then when you're looking through your documentation, you missed that. So make sure that everything goes through the documentation and you build based off the documentation. I know it sounds redundant, but it's kind of a big deal.
Thank you, Luke.
Sure. So now let's talk about implementation. So first, create your IP sets. You have to do that on the NSX manager itself and the web client. There's no IP set section in like Service Composer. You have to go into the network and security section, down to the actual NSX manager, then into grouping objects, and then there's IP sets in there. That's where you create those. So I just kind of created 4 dummy IP sets here. In that section, you can also create your security groups. Security groups can be created also in the Service Composer section, but while I'm already there, I usually go and just create them. But you can add multiple IP sets to a security group. You don't have to have a one-to-one relationship there. You can have a one-to-many. You can have a many-to-many as well. You can have your 2 different security groups like that. You can also create nested security groups, so that any IP set that's added here automatically gets added to this parent group, and this parent group might have dynamic membership based on a VM name. So if it triggers a name or a security tag or NSX tag or whatever from VRA, it can automatically get added to that group as well. So let's take a look at an example of creating a security group. Right here, this very first one, VM name contains 00111. So any VM that contains that string will get automatically added to this group. And so it doesn't have the name up there. But I also have one for 00400. So if you have a naming convention that can be programmatically deciphered, you can create all these groups based on names where it's dynamically populated, or simply a security tag of PCI. It gets picked up, it's automatically added to this group. Now here's where you can create it based on a single IP or a range of IPs or all IPs. This is an actual, /23, so that's the whole subnet blocked in there. And then, as I was saying, based on your dynamically based on your virtual data center. So any VM that lands in that virtual data center automatically gets added to this group. And so based on my virtual data center, that gets everybody in there. But if I want to exclude my PCI systems, I add it to the exclude list. Any VM that gets picked up as PCI gets removed from this specific group. Now, if you want to look at, let's see, there we go. So this is where Service Composer gets, you kind of have to wrap your mind around, am I offering a service? In this specific instance, I'm offering a service to these clients. So my traffic is initiated from outside, and I know specifically what I'm granting access to, like in my previous example, the web client. So I know I'm going to serve up the web client to these systems. So I would create my policy based on that I'm serving up the web client. So the destination is my web client, source is going to be a security group. Same exact concept here. I'm going to talk out to some other integration within my data center, whether it's a management, antivirus, any other integration that I need to talk to. Puppet, Chef, Windows, WSUS, whatever. Now, so when you're actually building your policy, you kind of think about it this way. You have a consumer that's going through a service that's hitting my security group. And of course, this is what this would look like if I was creating, this is an actual security policy with the firewall rule. So I have HTTPS inbound, that's just the name I gave it. So I say a policy security group is going to talk to my web server on HTTPS, I'm going to allow it. So that rule doesn't get applied to anything. It just creates the policy within NSX. This is the actual firewall rule that I edited. And you can see there's I just say policy security group. So any group that gets assigned gets thrown in here automatically. Action is allow, and I'm talking to my web server. And then of course you want to enable it, and you can log if you want, but then you also have the service of HTTPS. You could have multiple services there if you wanted to. You just hit change and add them in. Now the opposite, consuming a service. I have my security group that's going to talk out to something. So if you think about client push versus server pull, I have an agent on my server that's feeding information to something else. So LDAP as an example. So my local machines need to talk out to LDAP for authentication to something, I don't really know what yet, but I'm going to talk to my Active Directory or LDAP or EDIR or whatever on these specific ports, specific services. So same exact thing, but you notice these are flip-flop, source and destination. And then I have my services, allow, and then enabled and do not log in this specific one. So now when I look at that, what I do, when I'm applying it, the security groups that I want to either grant access to go here, and it could be multiple ones, or if I need to talk to multiple groups, they go there. So what it looks like when you're applying it, when you're in Service Composer, you have all your different policies. You right-click on it, you say apply, and then you say, okay, I want to grant access to whatever security or whatever group, security group, and they automatically get added, and it automatically builds the firewall. So in this instance right here, this is my security policy for my web server, and I want to say all local IP sets can talk to it. So that's what goes in right there. So all local IPs can now talk in. This is the actual security policy behind here, and if you click on it, I allowed access to local IP sets and global IP sets. Now, this is for AD off, and I have my global domain controllers. My systems are going to talk out to my global domain controller security group, so same thing. That's what goes right here, and it's saying my Windows servers are going to talk out on AD services to my Active Directory domain controllers. That actually builds these firewall rules for you. This is the actual view from the firewall section within NSX. I didn't have to create any of these firewall rules. Service Composer did that automatically for me. So now if I build a new Windows server and it's flagged as an OS of Windows, it automatically gets added into this group and automatically is in that firewall rule. I didn't have to do anything aside from just build the VM. So now, does this make a little better sense now, or is it still just text on a screen? So this is one of the key things that really helped me in implementation. Going through and following this, I had this built out and said, okay, I have all these policies built, then I know which groups I need to assign them to. It made it so much easier because the policies, I could look at all of them, and just building the policies, I didn't affect my environment at all. No impact whatsoever. Then I could go through and apply these. And that's when it starts allowing specifics in there. Now what we did in implementation, I don't think I highlighted here, the very last firewall rule within that firewall section when you're in NSX, and it looks like this, the very bottom one is the default rule. It's set to default allow, so everything that hits it gets allowed. When I went through and I assigned all these policies, I logged that firewall rule. And I started looking at my logs. We used Log Insight. And so I was looking specifically for everything that was hitting my default rule to see if there was anything I missed. Oddly enough, there was nothing hitting it because we had done so much planning and saw all the traffic up front, it was all accounted for. There were some random things where it was like Windows broadcasts for like NetBIOS or things like that we wanted to block anyway. So it was kind of a scary moment when we went ahead and flipped that default rule to deny because I thought it was going to break everything. You know, and I'm there at work and I went, okay, we're going to flip this to deny, and everything broke. Everything quit working. Come to find out, we had our DNS servers had VM tools that were so old, it wasn't reporting all the IP addresses for the VM itself, so it wasn't allowed through the firewall. And so we reverted the change, went trying to figure out what it was. I stayed at work till like 3 o'clock in the morning on the phone with VMware, and we finally figured out it was because VM tools were so old it wasn't reporting all IPs. Upgraded the VM tools on those DNS servers, did it again, everything worked fine, because at that point NSX was then aware of those IPs because they were VMs within the vCenter. Another thing that you can enable, I should have brought up, I didn't get a screenshot of that, is ARP snooping and DHCP snooping. How many of you use DHCP in your data center environment? Yeah. Good. We don't either. So enabling DHCP snooping doesn't really help you, but if you enable ARP snooping, NSX will keep track of the ARP requests and it'll start learning IPs from that as well. So if you have appliances or other VMs that don't have VM tools, instead of creating an IP set for them, if you have ARP snooping, it'll keep track of those and it'll start learning those IPs, and it'll learn them based on the VM, and it knows who's who at that point. So now, QSA overview. This is kind of the fun part. Anybody know what QSA means? It's the Qualified Security Assessor. It's your actual auditor that you have to defend your environment to, and they basically go back, say yes or no. You either failed or you passed. That was the fun part. So I'll kind of start at the high level. What I did was I started with my spreadsheet. I showed them that whole spreadsheet, and I went line by line, exactly what every single thing was, why we had it there, the purpose, the need, everything. And I worked my way, this is kind of a little out of place, but I went through and showed them everything there. Then I logged into my web client and I showed them, here's my security policies that map back to my spreadsheet, line by line, every single one. Then I went through and showed them how they're applied, every single group. I said, this is exactly how everything is applied. If you're not inherently, if you don't have access based on one of these policies or these rules, you're completely blocked. They were impressed with that. I didn't get any follow-up questions. I didn't have, after that, I think it was like an hour-long meeting, they went back to my security director and they were like, these guys are good, let's move on to the next group. And that's when he went to the rest of the groups and says, okay, now, the documentation, everything that these guys did, this is what you need to follow. So for us, it made us look really well, and that's how I'm able to tell you guys about it today. Because if this hadn't gone well, we probably wouldn't be here. But I had to explain to them how Service Composer actually kind of worked. But I showed them the firewall section and correlated it back. Because when you're in the firewall section, it lists the actual security policy name and then the rules in there. So you could show them then exactly how it's applied, exactly the ports that are in use. There are tons of troubleshooting things that you can run command line to see. If you're on a hypervisor, you can run these things and you can see exactly how they're stacked. You can see which IPs are in the groups. You can see how the ACLs are kind of laid out. And it looks similar to like a regular firewall with the objects and the access. But we don't have to deal with any of that. It's all fully automated through Service Composer and dynamic groups and everything there.
So any showstoppers when you did this, or did you have to go back and redo any of the tasks, or it was, sequential, it was all flowing through?
Yeah, it went really well, since I basically went through the QSA interview the same way I implemented it. Started at the top with my documentation, worked all the way down through that, went through the policies, went through the application, showed the firewall. What's up? You got a question?
Could you say something about the scoping process? Because we rented in a QSA to start up the project. Mm-hmm. And basically, everything that touches your PCI systems needs to be scoped in. So your monitoring solution, for instance, is your whole monitoring solution for the whole of Rackspace then included in the
So the question was, how did we scope everything, what's in scope and what's out of scope for PCI, correct? So I'm only on the VMware side of it, so our scope was everything VMware. So if it was a logging system that another team owned, we would look at what type of logs were being sent. And if that system specifically did not hold cardholder data or did not have access to cardholder data, it was de-scoped from our PCI. So in our environment, it's mostly the vCenters and kind of terminal servers that have access to the environment. Anything that can gain access into cardholder data, we put in scope. So all the vCenters, the PSCs, everything that could somehow be, if it was somehow compromised, would then leverage or be leveraged to gain that data. That's how we scoped it. Some of the logging stuff, if it was just a kind of low-level hypervisor syslog stuff, it may not have any cardholder data, it may not be used to get cardholder data, so it was de-scoped.
Did your provisioning system get pulled into scope?
Did the provisioning system get pulled into scope?
Tags, that if I tag a VM that gets created with PCI, it automatically goes into security group. So if that gets compromised and I go and deploy a VM with a PCI tag, I'm straight in. So did that get pulled in?
Well, even if it is pulled into the PCI, it's more of a lockdown firewall. The risk is if a system doesn't get tagged and is left out. But we actually don't use the security tags like that. We use it based on dynamic naming. So any VM that's built, say a new vCenter or a PSC, it's picked up with the name and is automatically added. And then that's actually a really good question and leads perfectly into the ongoing maintenance of this. So how many of you believe building...
You have a question?
Yeah, actually, how do you audit your, firewalls? Just, give them all, a lower and class rule deny everything.
Yes.
And what happens, at your first implementation of this firewall rules? Because, if something is missing, it could be a disaster. So how you will take it? Actually, I'm curious about that. Yeah, some of the season I heard about, okay, if you're sure about the one rules, close the logs and focus on others. Did you do anything, something like that?
So you're basically asking how we went through and enabled the default deny rule and being confident that we weren't going to block everything out. It was we implemented all the rules, and then we enabled logging on the default deny rule, and then watched everything that was hitting the default deny rule. So after several days, what's that? With allow.
Yeah, with allow.
With allow but logged. So we could see everything that wasn't caught above and hit the very last one. And if it was something we missed, there were some subnets that we missed for, I forget which integration, but something was missed and we had to go and add it to an IP set, and then it was missing from the other team's documentation, so we actually were able to tell them to correct their documentation. And once we set default deny, it was scary, but it still worked. One of the recommendations though, yeah, pretty much. Cross your fingers and hope it works. One of the recommendations, though, is if you have your vCenter within your management environment, is to exclude it from NSX. That works. You could do that. But the problem is our vCenters were specifically in scope for PCI, so we didn't want to exclude them. When we had the DNS issue and it blocked it out, I couldn't get back into my vCenter to disable it or to re-enable the default deny rule. But there's an API. By default, the NSX manager is not in, it doesn't get its own firewall. So you could use whatever system you want. I used a Linux system to send an API call to the NSX manager to disable the firewall completely. Once I did that, it turned everything off. I could get back in, I could fix the rule, and then re-enable it, or reset it to deny. And after I did that, everything was good to go.
And other things, you have one chart that consumer goes to the security group, also security groups goes to the target. How about the servers in the same security? Have you focused on that?
Yeah, it works similarly. So say if you have VMs that are in the same vCenter, you could think about it the same way. Well, I have a VM that has to consume another service that's next to it, and you can build a firewall rule based on that as well. So that's kind of where I was getting at, like the VMs that talk to each other. Within the non-PCI systems, we just allow any, because they're not secured. But within the PCI ones, we basically say they can't talk to each other unless it's on specific ports that we allow. So I can't show our actual rules because it's confidential, but we have, I forget how many rules we have in there that take that into account. PCI to PCI systems, PCI to non-PCI systems, non-PCI to PCI, and then management systems to be able to talk in are only allowed from specific VMs to be able to manage them. And so it's very locked down where even within the PCI segment, they can't talk to each other except on specific ports. So if a PCI system happened to be compromised, the blast radius is really small because it doesn't have full access to everything else inside the PCI bubble. Does that answer your question? Kinda?
So are you in the process of getting PCI compliant? Or?
No, but we are going to just start to, do segmentation.
Okay.
And we are on the planning phase, and this is a great, presentation.
So the planning thing, from the initial one, I would exclude your vCenter if your vCenter is in the same web client or same vCenter as your NSX manager. Go ahead and exclude it. There's an exclusion list. Put it in there for your initial testing, and leave the default rule to allow and log it's a DFW packet.log, I think, on the hype, and monitor what hits that. And so keep track of everything there, and you'll be able to see what's not being allowed higher up on the rules. So what I was getting at on the ongoing maintenance is PCI is not a set it and forget it. It's never over. You can't just get your PCI compliance and then you're done. You have to go through kind of an annual audit. You could get another audit in between sometime. So you need proper change control. And so what we did, we wrote our change control documentation says somebody has to submit a request saying, like say for instance, we have an application architect that's building an application that needs to consume one of our services. So he has to submit a request saying, I have either these IPs that need to talk to, say, the vCenter API or something on 443. So he has to submit that request with why. A member of our governing group that either says yes or no will either approve or deny, and then a member of an approved group can then go in and carry out that change. In this whole process, we add it to our approved spreadsheet so that the spreadsheet gets updated and then we implement based off the spreadsheet again. That really helps when we have our regular internal audit. So quarterly, semi-annually, whatever you do, you can then go and say, okay, I have my approved spreadsheet. It has all the changes. We even keep track of every single ticket, who requested it, who approved it, who implemented it, and the ticket number so that we can look back and reference and say, okay, these were added based on this ticket. And we can look in NSX and see that it's actually there. And of course, if there's any drift, we try to figure out why. Like if sometimes we build a new subnet and then we have to immediately add access to it because we can't build either servers or whatever. So we add it and then retroactively create a ticket. But there have been occasions where somebody forgot to submit a ticket on an instance like that. But we were able to pick it up, add it to our documentation, create the paper trail within our auditing system. And with that, I'd like to thank everybody. Yes?
What's about secure administration process and secure administration interface? So did you use NSX for securing VMs to level certification and so on for access for administrators of infrastructure?
So
did you use NSX to secure administrative interfaces?
So
security can be adjusted.
So you're saying how did we kind of lock down security to the administration stuff of NSX itself? So we use, we have multi-levels of access within our web client. And we only have one group that's only about maybe 6 or 8 people that have access to be administrators within the vCenter. And only that group is allowed to make changes within NSX. Everybody else is a security auditor, so they can go in and they can view the rules, but they're not allowed to change anything. So that goes back to like the change control and our, we have admins that are only, I think 6 or 8 admins that are allowed to go in and make these changes within NSX. And then it's all, of course, we have the paper trail, but it's also logged. We have syslog servers that keep track of everybody who's logged in. And within NSX, you can set Windows admin groups, or we use like LDAP groups to say who's allowed to log in. And so we create, we basically call it like Rackspace admins. And then it ties back to an AD group. Within vCenter, that's the vCenter group, and we add that vCenter group to NSX as the NSX administrator.
From the networking perspective, how do you control access to the administrative interfaces? We have our data especially request separate networks for administration VPN access.
So now instead of logging in, you're saying how are they physically blocking or putting perimeter around it? So we have everything's behind a firewall, and the only way to get into the environment is to go through what we call Bastion server. So you have to be a member of an LDAP group to be able to log into the Bastion server, and then from there you have to go. We have terminal servers within the environment that only allow login from the Bastion server. So you have to authenticate to the Bastion server, hop through that into the terminal server that is then locked down by only so many people are allowed to get into it. So outside of the environment, nothing can hit the NSX manager. Nothing can really hit the vCenter. So the only way to get in is it's multi-factor, like 2-factor authentication to the Bastion, and then your Windows authentication into the terminal server to be able to get to the web client to be able to administer NSX.
And one is making firewall rules for web client for NSX manager itself. It's external solution too.
Well, so NSX Manager is automatically excluded from the distributed firewall, so you can't lock it out. But the web client just runs on a VM, and so we're able to lock that down with the distributed firewall. And it's behind a physical firewall at that too. Yeah.
And how was operation cost? For example, did anything increase? Because what do you think? How many people just need to work dedicated to NSX? How was your operation change?
So
it's so important.
The operational change, there was a little bit of, I wouldn't call it overhead, but there was a learning curve for some of the operations to understand how to troubleshoot it properly. So there was a little bit of operational overhead in that regard. I wrote some documentation to help our engineers troubleshoot you know, if they can't communicate properly, how to go through and figure out if there's an NSX rule or if it's a physical firewall or if it's something else. But as far as operational cost, it was cheaper because we would have had to upgrade firewalls across all 8 geographical regions, which I think when I looked at that, it would have been $120,000 or so, and so NSX is cheaper than $120,000. And then you can find me on Twitter at @TapHuck if you want to reach out to me, and I have business cards if anybody wants to reach out to me any other time. And as always, please fill out the survey. I would appreciate your feedback. It helps us get better. If there's anything we missed, anything you wanted to see. But as always, if you have any questions, you can email me, hit me up on Twitter. I'm always interested in talking with the community.
Well, in closing, thanks a lot for taking time to attend this session, and hope it was informative. And as Luke pointed out, take a few minutes to fill out the survey. Your feedback is really important to us, so that we can come back next year with more information. So good information.
Thank you.
Thank you.